For that introduction, and thank you all to the attendees who have joined in all around the country. My name is Hasan Sarac, and I'll be presenting a few scenarios of 7-star NatHERS thermal performance assessments. This will be a light comparison of examples moving from 6 to 7 stars without the deep dive into the science of energy efficiency or entire passive house principles. A little bit about me, as Simon mentioned earlier, I have more than 19 years experience as a thermal performance assessor. I was first accredited in 2002, and since then my company has completed many thousands of assessments for volume builders to architects. I am a registered builder and have personally specialized in custom design and building residential homes for the past 15 years. I'm a member of the Design Matters National and of course the awesome Housing Industry Association, the HIA. Before we continue, this presentation is for discussion purposes only, and the scenarios presented are not definitive and are based on the assumptions and elements we have considered. It is important to understand that each assessor's and project inputs will vary the results. Also, the NCC 2022 has proposed new capped heating and cooling load limits in conjunction with achieving a minimum 7 stars, though the software has not been updated with the new climate files as yet, and therefore the final outcome could be slightly different from these examples presented. We'll run through a quick basic understanding of thermal performance assessments. For those who may not fully understand what it is, we'll get straight into some examples and finish up with a brief summary followed by Q&A. I do ask if you can leave all questions to the end of the presentation, and we will, and if we run out of time in the Q&A, I'd be more than happy to chat with you further at a later time. What we're assessing is how much energy is required to heat and cool a particular project. We're using software to model this performance, which is measured in megajoules per meter squared and illustrated as a NatHERS star rating. Some of the important elements which form part of an assessment are the orientation, layout, building fabric, surface colors, ceiling penetrations, shadings, obstructions, ventilation, and of course the climate zone in which the project will be built or currently built. In calculating the thermal performance of a dwelling, we tell the software which climate zone to be used. This is important as the exact same dwelling will perform different across all zones, which you'll see in the first example. As Simon showed you earlier, ABCB defines Australia into 8 climate zones, as seen on the map to the left. And NatHERS, the CHENF engine, which is used to model our assessments, has 69 climate zones, as seen on the map to the right. We're going to look at 3 examples: a detached single-story dwelling, an attached double-story townhouse, and a custom double-story dwelling. Due to time constraints, example 1 will be modelled across Melbourne, Sydney, and Brisbane. Example 2 and 3 will only be modelled in Melbourne alone. Scenarios for examples 1 and 2 will be played out in 4 different orientations simultaneously. This is to give you an idea on the importance of good orientation, as well as an instant visual on best case and worst case scenarios. As we move from 6 to 7 stars, consideration for good design and building systems will be more important, and I would love to be able to show you more examples than what we've got here today, and a lot more scenarios on different elements and how they will perform, as well as some little tweaks to designs that can be made. However, we can be here for days. Our first example is a 22 square single-story dwelling. Proposed construction is a waffle slab, brick veneer walls, tiled roof, aluminium window frames, 25/90 ceiling heights. Let's start off in Melbourne, which is a NatHERS Climate Zone 21. As you can see, our first example is a typical speculative floor layout. There are many thousands of variants of these layouts being built across the country, especially in urban growth corridors. Although this is a proposed design in line with NatHERS guidelines, we are assuming 2 equivalent dwellings to either side, as well as fences. This is really important that your assessor considers the existing dwellings, or at least assumes neighbouring dwellings if there are none, when you are modelling for 7 stars, as the results will vary dramatically. If we look at the center of the page, you can see 4 arrows with a circle and a number. These arrows represent the north orientation, and the numbers are the NatHERS star rating achieved for that north orientation. Immediately, we can see how the different orientations perform. The optimal orientation for this specific layout in Melbourne is north to the top or left-hand side. Melbourne being a more mild climate zone requires more heating energy. Therefore, good solar gain to living zones is very important. This specific design was able to achieve 6-star average across the 4 orientations with R3 insulation to the roof, R2 insulation to the external walls, excluding the garage, R2 insulation to the internal walls of the garage, no treatment to the floors. However, being a waffle slab, there is an element of thermal resistance considered due to the air pockets from the pod design and the thermal resistance of the foam pods themselves. Different pod profiles will have different levels of thermal resistance. In this scenario, we're using a 300mm pod profile, which has a thermal resistance of R0.6. Windows are aluminium single glazed and dark in frame color. Scenario 2 looks at what will happen if we increase the insulation levels alone. We increase the ceiling to R6.0 and the external walls and internal garage walls to R2.5. We could have used R2.7 high density bats in the walls, and I have seen people double up ceiling bats. However, we are keeping this simple and practical. Looking at the center of the page, we can see that on average, this had a positive gain of 0.6 stars with an average of 6.6 stars across the 4 orientations. However, we are still not quite at 7 stars. In scenario 3, further to scenario 2, we have also insulated the internal walls of the laundry, bath, and WC as highlighted in red on the plan. The reason why we did this is in most scenarios, these areas are considered to be unconditioned zones. Being an unconditioned zone, there will be a level of energy transfer between these zones. By adding a bit of thermal resistance, we can reduce this energy loss. As you can see, we gained a further 0.2 stars with this easy and cost-effective addition. However, further work is still needed to achieve 7 stars. Before we continue any further, I just want to briefly show you this diagram for those who may not have seen this before. This is the screenshot from First Rate 5, which is the modeling tool we are using. The different colors represent different zones. Easy to see how many different zones are being considered in this simple floor plan and how they are spread across this layout. Before we continue to increase the specifications randomly, we utilize the heating and cooling map tool on First Rate 5. What this particular diagram shows us now is the total amount of energy being consumed by each zone to heat and cool. We can also look at just the heating and cooling load separately, which is very handy in particular climate zones. This is a great tool to help with optimizing designs. The garage, laundry, bath, and WC represented in grey are unconditioned zones. Therefore, we are not using any energy to directly treat this volume of space. It is clear that the kitchen living zone is consuming the most energy as represented in red and orange. So we'll look at treating the windows in these zones first. In scenario 4, further to our additions in scenario 3, we have now double glazed the windows to the family, meals, kitchen, and lounge. The result, an average 7.1 stars across the 4 orientations. Now, before I continue, as mentioned earlier, we're looking at these 4 general orientations simultaneously, just as an overall comparison. In actual assessment, the orientation is always entered specific to that site. So in this case, if the north was to the right of the screen, further work will be needed to achieve NatHERS 7-star compliance for that orientation. So in summary, our speculative single-story example here in Melbourne, as an average over the 4 general orientations we looked at, this home will require an increase to the ceiling insulation from R3.0 to R6.0, an increase to the wall insulation from R2.0 to R2.5, the addition of insulation to the internal walls of the laundry, bath, and WC, and upgrading the family meals, kitchen, and lounge windows to double glazing. Again, this is just one way we could get there. There are many ways in which we could also get to 7 stars besides this one. I wanted to quickly show you what the results would look like if we changed to a concrete slab on ground, as well as a timber subfloor option. I've kept this to the optimal orientation only, given our time. As you can see, in this scenario, the concrete slab on ground requires an increase in the wall insulation to R2.7 high density bats, double glazing to all windows with the addition of an R0.5 slab edge insulation, A pretty similar outcome for the timber subfloor scenario, however, with the addition of R2.5 insulation to the underside of the flooring system. Clearly showing that for this example, a waffle pod foundation achieves 7-star with a lesser upgrade to windows and wall insulation over the other two options. Moving on to Sydney, that is climate zone 17. The optimal orientation for this example as is with north to the top of the page or to the bottom where they both achieve 6 stars and higher. Sydney being a warmer climate than Melbourne, in this example, the sliding door facing north is most likely causing a greater cooling load requirement and therefore reducing the star rating. If this window had summer shading, the result will be better for this orientation, which I will show you in the next couple of slides. Notice that as a base 6-star, the ceiling insulation is higher than that of Melbourne, even with the roof color being set to medium. In this scenario, similar to that of Melbourne at 7 stars, we increase the ceiling insulation to our 6.0 with the addition of sarking to the underside of the roof tiles, increase the wall insulation to 2.5, as well as the addition of wall insulation to the internal laundry, bath, and WC walls. We double glaze the same windows as per our Melbourne example, although we achieve a 7-star average across these 4 orientations. North to the left of the page is still at 6.9 stars. While double glazing all the windows would get us over the line for this particular example, I want to show you another solution. When we used our heating and cooling map as before, it was evident that the kitchen living zone was consuming the most energy, and therefore we wanted to show what a simple fixed shading device over the family sliding door can achieve. This is a 1 meter projection with 100% summer protection and 20% winter protection as set in the software, allowing for 80% of the winter sunlight to be received as solar gain through the family sliding window. Overall, a very good outcome with an average of 7.2 stars across the 4 orientations. This type of shading device will allow the residents to enjoy the natural sunlight throughout the year without overheating their living zone in summer. Now, being Melbourne based, I'm not that familiar with the building trends in Sydney. However, I wanted to look at what the good old 450E would do in this scenario. As you can see, for this example based in Sydney, this has a positive effect. We're able to achieve 7 stars average across the 4 orientations, even by downgrading the windows back to single glazing to all windows. If we double glazed one of the 2 windows to the living zone, we could achieve 7 stars even with the north orientation to the right of the screen. With the Sydney example, we saw 3 fairly easy scenarios to get our speculative example to 7 stars. However, again, I want to quickly show you what the results would look like if we change to a concrete slab on ground as well as timber subfloor option. I've kept this scenario to the optimal orientation again, just for time. As you can see, the concrete slab on ground performed pretty close with the waffle slab, only a 0.1 star difference. However, the timber subfloor requires an increase of insulation in the walls to our 2.7 high density bats, our 2.5 insulation to the subfloor system, and double glazed low E to the living mills, kitchen and lounge windows, and double glazing the remainder of the windows as well. Moving on to Brisbane, and that is climate zone 10. We immediately see good results as is, achieving an average of 6.4 stars across the 4 orientations. You can also see that both the roof and window frame color is light. We had to do this to bring the cooling load below the 31 megajoules per meter squared to meet the current 6-star heating and cooling load limit caps for this climate zone. By increasing the ceiling insulation to R6.0, wall insulation to R2.5, and insulating the internal laundry walls, we were able to achieve a 7-star average quite easily. Once again, comparing the waffle pod to concrete slab on ground, as well as the timber subfloor in the optimal orientation. As you can see in this scenario, the concrete slab on ground actually performs a lot better than the waffle pod system. We can actually reduce some of the insulation levels and still achieve 7 stars. We see that in hotter climate zones, as the ground tends to absorb the energy from the warmer concrete slab, whereas the waffle pod system has that slight thermal resistance, as mentioned earlier. However, the timber subfloor does not perform as well. Similar to Sydney, with the increase of wall insulation, all windows are also required to be double glazed low E. Now with the double-story attached townhouse, our example is based on a concrete waffle pod, mixed brick veneer and render foam cladding, metal roof, aluminium window frames, and 2590 ceiling heights. These types of projects perform well at achieving 6 stars, especially in the optimal orientation, and we've seen many of these projects and they do perform very well at a 6-star level. The shared boundary walls help with the reduced energy load by having conditioned dwellings on either side. In this example, we can achieve a 7.1 star rating with minimal effort. However, in reality, these types of sites don't always have the option of facing the optimal orientation, and although this example achieved a 6.4 star with little effort in the worst case orientation as per the previous slide, it requires increasing the insulation levels all the way up for the walls and ceiling, as well as double glazing what is essentially more than 50% of the glazing area to now achieve a 7-star rating. With north to the top or bottom of the screen, there is no ability to utilize solar gain through windows for these designs. Therefore, we need to insulate the glazing area to reduce the energy loss instead. We're almost there. Custom homes are an entirely different challenge. Often the client has an endless wish list of wants with a site orientation that favors something totally different. While I've seen well-designed custom homes achieve 6 stars with insulation alone, most require double glazing at minimum as well. So where do we go with these types of homes? This is an actual project that I personally designed and built for a client in Strathmore here in Victoria. We were fortunate that this site orientation somewhat favored living areas to the rear. As this was a sloping site, we also had great views to the rear that the client wanted to capture with large areas of glass on both levels. After a number of design tweaks and preliminary assessments, we decided on utilizing a suspended concrete floor system for the ground floor, timber floor joist system to the first floor, brick veneer to the ground floor walls, rendered foam cavity to the first floor walls, terracotta roof tiles to the roof, and a section of flat metal roof over the rear kitchen living zones. That was to ensure that we maintain the views of the second story, and white aluminium window frames. The white aluminium window frames were purely chosen for the design of the house in this case. We were able to achieve 6 stars with our 5.0 insulation to the pitched tiled roof area, our 4.0 insulation with an R1 anti-condensation blanket to the flat metal roof section, our 2.5 insulation bats to the external walls and the internal garage walls. We didn't need to insulate the suspended concrete slab. We added our 3.5 insulation bats to the first floor area over the garage, and all windows were double glazed for this design or for this project to achieve 6 stars. So how to get this design to 7 stars? If we look at maxing out the insulation levels for this type of construction, as well as adding R2 rigid insulation boards to the underside of the suspended concrete slab and adding insulation to the internal laundry walls, we only gain a further 0.5 stars. We're still 0.4 stars off our 7-star goal. Again, utilizing the heating cooling load map tool on first rate 5, we can identify the zones that are consuming the most energy and start with addressing the glazing in these areas. It is evident that the kitchen living zone to the ground floor and the upstairs rumpus are consuming the most energy per meter squared. So what we have done is we've upgraded the double glazed windows to these 2 zones with high performance double glazed low E glazing systems, and this assisted in achieving 7 stars. But what if this scenario was different? What if the north orientation was flipped, but the client still wanted the living zones to the rear to capture the awesome views that they have? Although we tried utilizing double glazing low E to all the windows, we still had to upgrade the largest section of glass to further higher performance window system. By using thermal broken aluminium double glazed low E glazing to the large stacking doors to the mill's alfresco area, we were able to achieve that 7 stars. I completed this build in 2019. My clients have had the chance to experience the difference from their previous 1950s 0-star 18 square home to their new 6-star 4.8 square home. To their new 6-star 48 square home. And feedback is outstanding, and the thermal comfort across both levels, as well as their energy use, far outweighed their expectations for such a large family home. Moving to 7 stars should further this performance and experience. However, I do ask that as builders, designers, and architects, we need to ensure that this further increase in thermal performance does not compromise the beauty of our homes, abundance of natural light, and importantly, the health and safety of the homes we design and build. Just a very quick recap before I wrap up my presentation. The importance of good design and orientation specific will assist in reducing the specifications to achieve 7 stars. It is evident that in most cases, we will need to increase the insulation levels as much as possible for the type of construction being used. The use of double glazing will increase, and we will see a lot more double glazed low E use also. Fixed summer shading is also a good way in reducing the summer loads of homes, and especially to warmer and hotter climates, while still maintaining balanced glazing areas. Cooler climate zones may need to consider insulating the slabs or possibly utilizing raised flooring systems, and that's to decouple the foundation, the flooring from the ground itself. Another easy and effective measure, and these are sort of some low-hanging fruit, will be to reduce the amount of ceiling penetrations in a home. We didn't look at these examples here today. However, there are some significant differences, especially in homes that have a lot of ceiling penetrations. So by either opting for good quality IC rated recessed lights or surface mounted lighting options, recessed lights, downlights that are not IC rated require a clearance right around for safety, depending on the amount of downlights you have in a home. This can add to a significant loss of thermal resistance to the ceiling area. I hope you enjoyed this very brief and quick presentation. I now welcome any questions. If you'd like to get in touch with me to discuss energy assessments further, please send me an email or call 1300 88 3379. Thank you.